Hi ladies, in this video we're going to go through inverse matrices. Now there is another video on this, but I'm thinking maybe explaining it another way will help you better understand what it means by taking the inverse, first of all, of something. Okay, so I'm going to start just by giving you a general introduction to what it means. I might stick with pink. Sorry, I'm just choosing my color over there on the left that you can't see. What it means by the inverse. So let's take a number. Let's choose a number 8 because I always think it's pretty cool. All right, so 8, let's say we multiply that by something, equals 1. What do we multiply that 8 by to get to 1? Now you can usually use algebra. So let's say we had 8x is equal to 1. That means we'll divide both sides by 8. So x is equal to 1/8. Okay, so 8 times 1/8 equals 1. So that means that this is your inverse. Basically, what number do you need to multiply 8 by to get to 1? And it's the same for any integer. So let's say I did the number 2. 2 times 1/2 is equal to 1. Okay, so this is its inverse. Well, they're each other's inverse, but 1/2 is the inverse of 2. 2 is the inverse of 1/2. Now, if you've done surds or indices before, you may have seen the notation. I don't know why I keep using different colors, but I'm going to. The notation 8 to the negative 1, or you may have seen x to the negative 1, or k to the negative 1, and that just means it's 1 over. Okay, so that symbol to the power of negative 1 implies the inverse. Okay, so whenever you see a matrix, here's a matrix to the power of negative 1, it is the inverse. All right, so that's just a brief lesson on what the term inverse actually means. Now, why we use it in matrices is because when we multiply a matrix, and why not get another color? So I might use this light blue. Okay, let's say we had a matrix A. Okay, it doesn't matter what the numbers are for now because we're going to do a few proper examples in a second. And we multiply it by its inverse. In matrices, it doesn't equal 1 because we don't have matrices that we're working with. Sorry, I just had a blank. Working with whole numbers. We work with matrices. Now, what we get here is what we call there's already an I there, the identity matrix. Okay, that is a matrix that is equivalent to 1. So when we multiply these two together, we get the identity matrix. So the identity matrix, depending on what the order of these two are, will have number 1s down its diagonal and 0s everywhere else. So this is a 3 by 3 matrix. And you can only take the inverse of a square matrix. So there's a 2 by 2 matrix. Okay, so if this was a 3 by 3, its inverse would obviously also be a 3 by 3. Its product, the identity matrix, would look like this. If it was a 2 by 2, its inverse would also be a 2 by 2. Its product, the identity matrix, would look like this. The reason we use the identity matrix, just like we do in algebra, we want to solve equations or undo things. Okay, so that's basically what we're using the identity matrix with. All right, so there is a formula for the identity matrix, and I've created a video just on the formula. So obviously anyone can plug into their calculator a matrix to the power of negative 1, but you also need to know how to do it by hand. All right, so magically all my scribble has disappeared, and here is a nice screenshot from Google of the rule for an inverse matrix. Okay, so and I should say here at this point, you only ever have to do the inverse of a 2 by 2 matrix by hand. If you had to do an inverse of anything greater, so maybe a 3 by 3 matrix, you do that on your calculator, but you need to know how to do this by hand. All right, so what we've got here is a 2 by 2 matrix. The A, B, C, and D just represent any numbers. All you need to do is identify what the A, B, C, and D are and plug them in to this formula. So I'm going to write on the right-hand side an example. So let me just get my pen up. Which color would I use? Let's go back to pink. Okay, and I'm just going to choose 4 random numbers. I have no agenda in this at all. I do hope the numbers I choose work, because you can't always take the inverse of a matrix, and I'll explain why in a second. Okay, so we've got our 2 by 2 matrix. What you need to do is identify A, B, C, and D. Now you can either write it next to it like I am now, and it does matter what you label A, B, C, and D. It has to be in that order. Or you can say A is equal to 2, B is equal to 3, C is equal to 1, and D is equal to -1. So in our formula, and I don't know why I keep choosing different colors, all we need to do is plug in these values. So our inverse, so here's our original matrix, and I'm representing that as an inverse by putting to the power of -1 is equal to 1 over, and now I start plugging things in. So A is 2, so I'll put a 2 here. AD, when they're together, it means multiply. So it's A times D, where D is -1. And then we've got minus B, so -3 times C, so 3 times 1. I might just move that over. And then we've got our matrix. So D and A switch spots. Okay, so you can see how they used to be AD, now it's DA. So D is -1 and A is 2. And C and B stay in the same spot, but they change signs. So if they were positive before, so see how C and B were positive before, they become negative. But if they were negative, they become positive. So in this question, they're both positive. So B becomes -3 and C becomes -1. Okay, so -C, -B. All right, let's scroll down. Oh, ladies, I just went through and had to delete a big chunk because I stuffed up this part. I did 2 times -1 is -3. 2 times -1 is -2. And I didn't realize until I did it on the calculator. All right, -3. So just doing that fraction first. This matrix just stays the same for now. It's always weird when I edit stuff out of a video because you may not know that I've done it, yet I always tell you that I have, and it probably just seems a bit weird that I'm talking about something that you can't see has happened. All right, so this fraction part becomes -1/5 once I do -2 minus 3. Now, if you can get to this point, that is fantastic. You have shown enough working to do this matrix by hand. And some people struggle with their negatives, okay? So not really struggle as in they don't know how to do it, but they're more prone to making mistakes when they're dealing with negatives. So if you are someone who is like that, I would encourage you to put it in your calculator at this point. But let's go and do it. So this is a scalar multiplication. That just means everything inside this matrix is multiplied by -1/5. I'm just going to scroll up a bit so we've got a bit of space. So this first element, -1 times -1/5 gives you +1/5. Then in this next spot, we're going to have 3/5, and then 1/5 again, and then -2/5. So all I've done is multiplied through this scalar, the 1 over -5 or -1/5. Now, I just did this on the calculator before I deleted part of the video. So I'm just going to show you now. Let's make it a bit more viewer friendly. Come on. Oh, I'm going to scroll you over. Okay, so when you're doing it in your calculator, you just type your matrix like I have done here. So your original matrix. So at the start of the question, it was 2, 3, 1, -1. And then you do it to the power of -1. So remember I explained at the start of the video, the inverse is defined as to the power of -1. And then you get your answer. Okay, so easy peasy to do it on your calculator. By hand, a little bit more complicated. All right, so remember at the start of the video, I told you the reason for doing the inverse. So if we had matrix A and we multiplied it by its inverse, we get the matrix equivalent of 1. Okay, and I explained that as being your identity matrix. So in this case, because we're dealing with 2 by 2 matrix, it's 1, 1 down the diagonal and zeros everywhere else. So matrix A, which if I just scroll up, can be this matrix here. And then its inverse is here. So if I did matrix A times its inverse, this is the matrix I will get. Okay, the identity matrix. So it's kind of like, you know, in algebra when we want to undo something. So if we've got numbers that are multiplied, okay, so let's say we wanted to, like I said at the start, if we wanted to do 8x and we wanted to get x by itself, let's do 1, we multiply, oh, actually, sorry, I shouldn't say we multiply. We divide both sides by 8, but effectively that is the same as multiplying it by 1/8. Okay, so dividing by 8 is the same as multiplying by 1/8. Okay, so it's kind of this exact, well, it's very similar to what we're doing here. Now I'm going to show you on your calculator how we get that identity matrix. So I'm going to get the calculator back up, just in case you don't believe me that that is what we're going to get. So our original matrix, and I'm going to cheat and just do some copying and pasting. So there's our matrix. We called it matrix A. We're going to multiply it now by its inverse, which is here. And there's your identity matrix. Okay, so remember it's the equivalent of 1. The other thing with identity matrices is the determinant. So some of you are saying you didn't understand what the determinant was. So the determinant, and I've got so much writing on the screen. Let's use a nice bright color, green. The determinant is just this part under here. Now, when you think about that, that's the denominator of a fraction. So when we've got fractions that are 1 over 0, we say they are undefined. Okay, so we can't do it. So this part here, the determinant, is just telling us whether we can take the inverse or not. So AD minus BC is your determinant, and if it's equal to 0, then you can't take the inverse. So if I go back to my calculator, okay, you can do the determinant by hand. Oh, sorry, by hand. Well, we've already done it by hand, but you can do it on your calculator. So you just type in DET and then put in your matrix. So we're doing this first matrix. So I'm going to copy it and then put it in here. And there it is, -5. And remember that we found it here. Where is it? And there it is there, the -5. And I might just circle that in green. Okay, so that's what the determinant is used for. So you can do it by hand quite easily, because with inverse matrices, they're not complicated. It's just a matter of being able to identify A, B, C, and D. Now, their application in bigger problems might be a little bit more complicated. So I might just do one example of when they're mostly used. All right, so here's my example with simultaneous equations. So you know how to solve simultaneous equations by probably using your CAS calculator, but then nothing new to you. You know they represent just two lines. Okay, I'm not doing these exact lines, but we have, so let's say this was one of those lines. Okay, so they're basically linear equations, and there's the other line. So where they cross is their solution. There is situations where they don't cross, okay? And that is when they're parallel. And remember when I was talking about the determinant, that's what basically the determinant is saying to you. We can't find us, there is no solution, basically because these lines do not cross. And there's another type of solution if we have two lines that are basically the same line. Okay, so they're on top of each other. Okay, so we call this a unique solution, no solutions, and infinite solutions. Now, this is probably beyond Year 11 General Maths, but if you do maths methods, it's something that you'd probably be introduced to this year, but definitely next year. But for general maths, you just need to know, well, how it applies to your determinant. All right, so let's get back to the question. All right, so we can solve these set of equations, obviously, on our calculator using solve. Okay, or we can also do them by hand. Some of you might remember how to do simultaneous equations by hand, but I'm going to show you how to do them using matrices. Now, when you do them in matrices, the order of your X and your Y matter, okay? And basically they have to be in this form where you have your X, your Y, and then your constant. Now, if they were around the other way, they can be Y, then X, and then your constant, but just make sure that your matrix equation reflects that, okay? And I'll explain what I mean in a second. So your first matrix is made up of the coefficients. So we just go along in a line. Don't worry about what's happening on the right-hand side, just the coefficients of the X and the coefficient of the Y for the first equation. So the coefficient of X is 2, and the coefficient of Y, now we don't usually write, but there is a -1 there. Okay, so it's -1. Then for our second row, we've got the coefficient of X, which is 5, and the coefficient of Y, which is 2. Now, this is why I was saying your variables matter. Now, if your variables are written X, Y, then you write them in that order here, X, Y. If they were Y, Z, you write Y, Z. If they were T, Q, you write T, Q. But they all have to be in the same order, okay? And we're going to be multiplying that. And then it's equal to your constant. So we've got 3 and 1. Now, when you think about this, this is basically a matrix multiplication. Okay, so if I was to go through and multiply this first row by this column, you're going to get 2 times X, -1 times Y. But we know in algebra, we have to get the X and the Y on their own. And the way we do that is usually by multiplying by the inverse. So we've got to take this first matrix. So if we want to get X and Y on their own, we multiply this matrix by its inverse. Okay, and I might just put that down here. Okay, so we're multiplying it by its inverse. And whatever we do to the left-hand side, we have to do to the right-hand side. Now, in this sort of multiplication, the order matters. Your inverse always goes first. Okay, so when you go to write your inverse on the right-hand side, so we've got 2, -1, 5, 2 to the power of -1, and then 3 times 1, sorry, 3, 1. All right, so your inverse always has to go first. So we're solving for x, y. Basically, what we're left with when we multiply this first matrix, this matrix here, by its inverse, remember I said you're going to get the identity matrix. Okay, so that's what you got by doing that. It has usually we say it disappears. It doesn't really disappear, it's just one. So effectively this green matrix, identity matrix, is just multiplying x by y, which is 1. Okay, so we don't usually write the identity matrix there. All right, so let's solve for x and y. Now you do need to know how to do this. Let's do the identity matrix by hand. So we're going to have 1 over, now I can't remember that, I think it was AD minus BC. All right, just had to check on Google again. So D, A, and then this is negative B, negative C. So I probably should have done this before, but that's okay. And then we've got 3, 1. So all I've written here is the formula for the inverse. Okay, let's scroll a bit. Now, I haven't labeled A, B, C, and D just yet, but here it is. There's A, this is B, this is C, and this is D. If you want to, you can say A equals 2, B equals negative 1, C equals 5, and D equals 2. Okay, so you can either label them on your matrix or you can write them on the side like I've just done. All right, so let's put those values in. So A times D, so we're going to have 2 times 2, which is 4. B times C, so negative 1 times 5 is, let me make sure I don't make a mistake this time, is negative 5. And then we've got D up here, which is 2, negative B. Now B, because it's already negative, will now become positive, and C, before it was positive, now it becomes negative. And I just noticed that A and D are both 2, which doesn't make it ideal, but it's all good. All right, and then we've got the 3, 1. All right, so let's just scroll. So I'm going to have 1 over 9. And then I've got this matrix here. Now, at this point, you don't really need to do the rest. Okay, if you can get up to this point, that's great. I would then just do it on the calculator because, first of all, you've got this scalar multiplication and then you've got this matrix multiplication. So let's put it into the calculator. I'm not trying to be lazy here, but I'm being realistic. Okay, so I'm going to, can never see my matrix. Let me just write it down and then I'll remember a bit better. So we've got 1, 9, 2, 1, negative 5, 2, 3, 1. All right. Just bear with me. Oh. My calculator on the side, as you can see, is so tiny. Okay. So, oops, I forgot the scalar. So let's just put the scalar on. So what was that? 1 over 9. And we got 2, 1, negative 5, 2. And then we're multiplying that by, and I didn't put a multiplication sign in here, so I'm just going to put a multiplication sign in as well. Probably don't need to, but just in case. And then we've got a 2 by 1 matrix, so 3, 1. And there's your solution. So what have we got? 7 ninths and negative 13 over 9. So I'm just going to write that down. Okay, so remember we're solving for x and y. So that is equal to 7 over 9. And then in the next one, negative 13 over 9. So your solutions, we just read them. X is equal to 7/9 and y is equal to negative 13 over 9. Now, I'm not going to go and do these simultaneous equations by hand, but let's just go back up and I'll show you how it works on your calculator. So if you were to check these, check your answer, you can, I'm just writing down the question as I'm talking. You can just solve it as a linear equations. So you can type in solve, type in your two equations. So what do we got? 2x minus y equals 3 and 5x plus 2y equals 1, comma x. And this is always the scary part, pressing enter, but you can see there are your answers. Okay, so the good thing about matrices is you can always check your answer. The bad thing is you need to know how things work, so make sure you can do it by hand. Just before I finish, some of you told me today you had trouble with the decoding section, and I'm more than happy to go over that with you maybe in person. The reason I'm not going to show you again here is because I've only ever seen it in that textbook. It is not on the study design for further maths, but you are assessed on it because it's a good use of the inverse matrix. So it's good to understand how the inverse matrix actually works. But it's not something that I, in my many years of experience with further maths, have ever seen. So if you're comfortable just to think, well, I'll go through the question on my test, but I think I'm good to probably leave it at that. All right. Bye, ladies.